Hello. In this video, we're going to continue solving trig identities. And in this case, we're going to look at ones that have this 2x, or the double angle, but with some more advanced techniques. So here we have tan of 2x over 2 sine x cos x equals secant 2x. So we can go ahead and draw a line down the middle, and I'd encourage you to pause the video and give it a try, see what you come up with. All right, so this identity is actually better to leave in the 2x form, because if you notice, this is a 2x and this is a 2x, and 2 sine x cos x, we could make it a 2x. Normally, we've been taking sine of 2x and writing it as 2 sine x cos x based on the identity, but we could take it the other way. Instead of going this direction, we could go this direction. So the bottom can be rewritten, this bottom portion can be rewritten as sine of 2x. And the top will be tan 2x. Now over on the right side, we have secant. We can write that as 1 over cos, and of course it'll still be a 2x. Now they don't look the same, but at least everything is in kind of like a 2x form. So that's kind of helpful. Tan we can write as sine over cos, so sine 2x over cos 2x, all divided by sine 2x. Now we got to work with that whole fraction in a fraction business. Remember, we can write this as sine 2x over cos 2x. And when we divide by sine, it's the same as multiplying by the reciprocal. So this right here, this means division. And we're going to turn it into multiplication right here. And then we're going to flip the sine 2x as, right, you could imagine this as over 1. So then we put it 1 over sine 2x. And the reason we do that, of course, is the sine 2x cancels. And so we get 1 over cos 2x. And what do you know? Left-hand side equals right-hand side. Now let's look at another one. Cos to the 4x minus sine to the 4x equals 1 minus 2 sine squared x. So again, I'd encourage you to pause the video and give it a try. Now on the right-hand side, I think this looks like a cos 2x. And so again, normally we were taking the cos 2x identity, and we are writing it as maybe cos squared minus sine squared, or 1 minus 2 sine squared x. Normally we went this direction, but we could go this direction. Now that might be good, it might be not be good, but we'll just see. We'll see what happens. On the left-hand side, well, those are power 4, and we don't usually do power 4. Usually we do power 2. But I want to show you something. This is kind of an interesting question. If I had x to the 4 minus 16, this could actually be factored because x to the 4 is x squared squared, and 16 you could write as maybe 4 squared. So this is it's like a difference of squares. This becomes x squared minus 4 and x squared plus 4. So even though it's a power 4, it's kind of like a difference of squares. If we try to do the same idea here, we can see this is cos squared squared, because 4 is the same as squared squared, and sine we could write as sine squared x all squared. Now that's going to look like cos squared x minus sine squared x, and then cos squared x plus sine squared x. Now, why would I do this? Why would I take a power 4 and factor it as a difference of squares? Well, obviously because each one of these now has an identity. If we look at cos squared x plus sine squared x, we know this is just going to be 1. And if we look at cos squared x minus sine squared x, we know this is going to be cos 2x. Again, kind of like reversing that. If you look at the right-hand side on your formula sheet, you'll see a cos squared minus a sine squared. So you can reverse it back into the cos 2x. These are multiplied, and cos 2x times 1 is just cos 2x. And sure enough, the left-hand side equals the right-hand side. So a bit of fancy factoring there with the powers of 4. Again, if you're struggling with that, I would encourage you maybe even think of it like this, right? If we had x to the 4 minus y to the 4, we could factor that as x squared minus y squared and x squared plus y squared, right? Each one of these is a perfect square. It's like x squared squared. It's like y squared squared. And that allows us to do the factoring. If you multiply it out, right, x squared times x squared is x to the 4. Then we get a plus x squared y squared, a minus x squared y squared, and a minus y to the 4. These cancel out, and we're back to where we started. So with that one little factoring insight, it really opens up the whole identity. All right, here's another one. We have cos squared plus cos 2x over cos squared equals 2 tan squared. Go ahead and pause the video and give it a try. All right, now assuming you gave this a try, this one is tough. Because again, some people might be tempted to cancel those cos squareds. But remember, this is not legit. Because of this plus sign, we have two terms and we cannot do this. But we could do something similar. If you really feel like you want to cancel something, you can split each one of these terms over the cos squared x, because there's only one thing in the denominator, cos squared, and so you can uncommon that denominator. Now cos squared over cos squared, that'll become a 1. And over here, we could write cos 2x as maybe cos squared x minus sine squared x over cos squared x. Well, hey, we've got that same setup. We have two things over top of one thing. We can't cancel these, but we could split it again. So this will give us cos squared x minus sine squared x over cos squared x over cos squared x. And don't forget about that 1 we had over here. Now we can turn that cos squared over cos squared into a 1. We got another 1 over here. And maybe I'll just leave this as a sine squared over cos squared just for right now. Now 1 plus 1 is 2. So I have 2 minus sine squared over cos squared. And over here, I have 2 minus 10, we could write as sine squared over cos squared. All right. Left-hand side equals right-hand side, and we're good to go. Now, there are other ways of doing this question, and this might not have been the way you chose to solve it, but it's the way that made sense to me. And again, as long as you have the same thing on the left and the same thing on the right at the end of the question, as long as you didn't break any algebra, your solution is still valid. All right, let's look at another one. 2 sine x cos x minus tan x over cos 2x equals 1 over cotan. Well, go ahead and pause the video and give it a try. Okay, the 1 over cotan, I'm going to make that just right into a tan, because 1 over cotan is the same as tan. And then I'll maybe make that a sine over cos. Now on the left side, I think we're going to have to get rid of that cos 2x, because here we have a cos x on the bottom, and here we have a cos 2x. Those are never going to be the same. So I think the first thing to do is to work on that cos 2x. And again, we have a couple options. I'm going to try for that second option. I'm going to go for 2 cos squared x minus 1. And then here I have, well, I could write this as sine 2x minus tan x, but that's actually not a good idea, because I'm trying to get everything into just x's, and if I go back to 2x land, then some of them are 2x's and some of them are just x's, and that's not going to work well. So let's not do that. Instead, we can leave this as 2 sine x cos x, and we'll make the tan a sine x over cos x. I think things are going to get worse before they get better. We have to common denominator in that fraction. Ooh, yikes. Okay, so this will give us 2 sine x. Right, if you imagine this guy as all over 1, we need to multiply by cos and divide by cos. So that's going to be cos squared, because there's going to be 2 coses in the top. Yikes. minus sine x over that cos x, and then all over the 2 cos squared x minus 1. Okay, I probably should work on those fractions and get them together, because having the fraction in the fraction is pretty messy. So let's write it as 2 sine x cos squared x minus sine x over cos x multiply by 1 over 2 cos squared x minus 1. We're trying to make this fraction a little simpler. Well, I guess I could write this. Times 1 doesn't do anything, so we have 2 sine x cos squared x minus sine x divided by cos x. Let's keep this unmultiplied right now, just because I'm not really feeling it. I don't want to multiply it out yet. Well, if we look here, there's kind of like a 2 and a 2 here. And there's a cos squared and a cos squared. And if you notice, this is going to be our key insight. There's a sine here and a sine here that we can factor out. So if we factor out the sine x, we're going to get 2 cos squared x minus 1 over cos x 2 cos squared x minus 1. And this is great news because these cancel out. And we just get sine x over cos x. Oh, thank goodness. Left-hand side equals right-hand side. I wasn't sure we were going to make it there, but in the nick of time, we found a sine x that was in common, and we were able to factor it out. And this is sometimes what happens. Your question feels like it gets worse before it suddenly gets better. When you're doing identities, sometimes things have to get a little more complicated, but eventually you should find something that cancels and simplifies it down. All right, so there's not really anything new today in terms of notes. Maybe you could write down that factoring trick of x to the 4 minus y to the 4 is x squared minus y squared, x squared plus y squared, right? This is based on the idea that if you had x squared minus 9, it's like x minus 3, x plus 3. So this is called a difference of squares. Difference of squares, and over here this is like a super version. So it's the same thing but just more complicated. So like a super version of difference of squares. For an example though, I do have a nice one here I picked out. Tan squared x over 1 minus tan squared x equals sine squared x over cos 2x. So go ahead and pause the video and give that a try. All right, so let's go ahead and give this one a try. I might need a little more space here. So there's not really an identity for 1 minus tan squared. It's actually 1 plus tan squared. So our best bet is probably to go with the root of sines and coses. So sine squared over cos squared all over 1 minus sine squared over cos squared. Now, if you didn't get this as a first step, pause the video and see if you can finish it off from here. But yeah, we've got to make it worse. We've got to make this a common denominator. So this will be multiplied by cos squared x, cos squared x. My goodness, this is going to look like a mess. And that's sometimes what you have to do. You have sine squared x over cos squared x divided by this mess, cos squared x minus sine squared x all over cos squared x. Now, we've talked about this before, but these cos squared x's will cancel, but we have to maybe set them up in that fraction version so you can see it clearly. So this will become sine squared x over cos squared x. We flip and multiply the fraction, so cos squared x over cos squared x minus sine squared x. Then we cancel these. That's going to give us sine squared x over cos squared x minus sine squared x. And we can write sine squared x on the top. At the bottom, we can reverse the identity as cos 2x. Now if we just check back at the top, we had initially sine squared x over cos 2x. And so we're good to go. The left-hand side equals the right-hand side. Again, trying to encourage you to not be afraid of giant fractions. Sometimes these identities do have to get pretty complicated, but in the end, they should work out. Now, for an example for you to try, you're welcome to look at Unit 7, Worksheet number 6. And for any things to remember, really anything that sticks out to you, just so you know, if I have cos 2x, I could write that as just a cos 2x. I don't have to put the brackets around it. I do like to, and so I generally try to put the brackets because I think it's a little clearer, but just so you know, these are both fine. All right, hopefully you enjoyed this video, and as always, thanks for watching.